All right, welcome to the study of hair. So you've witnessed the objectives for this topic. Giving you a little bit of history, in 1883, this topic of hair was covered in the first forensic science text, and a more comprehensive study of hair was done by a couple of scientists in 1910. And then 1934 was really the first documented case of looking at hair, comparing one to the other in terms of their likeness and differences. And today, the science has progressed to include chemical tests, neutron activation analysis, which we'll talk about in a little bit, and possibly DNA analysis depending on what part of the hair is there. So the function of hair, whether you've thought about it or not, it's not necessarily to provide Lady Gaga her identity so much as to regulate body temperature, and this is true for all mammals. Also decreases friction in terms of sliding motion, and can protect against sunlight. So the way that a hair is structured is that it has 3 layers, and the innermost layer is the medulla, and this is very rich in pigments. The cortex is this middle section, and then the cuticle is the very outermost section here. If you think about it as an analogy with a pencil, the medulla would be the graphite, the cortex would be that cork-looking type pencil piece, the majority of the inner part, and then the cuticle would be the outside, like that yellow shell that you see. Within the skin cross-section, you see that the hair follicle actually begins deep down into the dermal layer. So the skin surface is here, the epidermis is just under that, that's the outermost layer of skin. The dermis is under that, and that includes the pore which the hair exits through. The hair is also often joined to a sebaceous or oil sweat gland. The papilla of the hair connects with a capillary, which is the source of nutrients for the hair, and then the subcutaneous tissue is where the capillary extends into. So in looking at the cuticle, the outermost layer, there are often overlapping scales that you can see, which also vary in shape and texture depending on the species. We'll take a look at that in a little bit. And the cortex is the thickest layer. Often the cortex does contain a lot of pigment, and the cortex is often denser near the outside, near the cuticle. Now, in looking at the medulla, or the innermost portion of the hair, you can range from not having any medulla, which is actually my hair. When I look at it under the microscope, I'm absent of any medulla on my hair, to someone having a totally solid medulla where the pigment is so great that it fills the entire cortex as well. You can have a continuous medulla that's just a straight line all the way through, interrupted or intermittent, where it's like a dashed line in the middle of the road, and then fragmented or segmented, the difference here being that it's an uneven break, uneven spacing in the medulla. When you exit just the human species, which is what defines these types of medulla patterns, you actually can see some other types of medulla patterns, which you see down here, and we'll take a look at a couple of hair samples from different species as well. Now, there are a couple of different shapes for the hair. Buckling often occurs with hair that comes from different body parts. Pubic hair demonstrates this. This can affect the shape or curl of the hair. Blunt can refer to the end, like a lot of times a whisker or something that's shaved off would have a blunt edge. And then another thing that can happen is actually a double medulla, which you see here, and some people demonstrate that. Also, the cross-section shape can be any range from circular, triangular, or irregular flat, and the texture obviously can be different. As we touched on a little bit, human hair varies depending on what body region that it's from, so that would definitely affect forensic investigation. Whether you're evaluating a lash with another lash, or beard hair, underarm hair, etc., ideally you would be comparing one body type to another. And head hair would be the most common used in criminal investigation. Now, this is kind of interesting. You may never have thought of your hair as having a life cycle, but it does. And the anagen stage is the active growth stage. In this portion, nutrients are being brought in, and there is active growth happening as cells around the follicle, this base portion, are dividing and depositing materials into the hair shaft. The catagen stage is kind of like being over the hill. This is when the hair continues to grow and change, but as you can see, the nutrient distribution is really lessening, and then that leads to the telogen stage, and that's when the follicle becomes dormant. From that time, the hair can fall out naturally, and the average human loses 100 hairs on the head per day. And this is why. So, in terms of changes that humans can impose on their hair, bleaching is one of those changes, which will actually disturb the scales on the outside of the cuticle and remove pigment, can leave it kind of brittle. Also, dyeing hair will change the color of both the cuticle, the outermost layer, and the cortex, the middle layer. So there are some differences which can be observed generally among different races, and you remember that the three terms for the ethnic groups in forensics goes back to Caucasoid, Mongoloid, and Negroid. And so I'd like you to think about which of these hair samples you think might reflect those different people groups. So if you're thinking for the leftmost one here, Caucasoid, then you'd be right, because you see a lot of variety. There's a medulla here. This one has a little bit of medulla, but it's faint. This one may be faint and fragmented. You can also have hair without a medulla at all and different colors, and that's more common among Caucasoids. As you see here, the cortex is really filled with pigment, and you can't discern a medulla at all. That's often characteristic of Mongoloid, and the buckling and curliness here that you see, along with a variation in the cross-section shape from circular to kind of flat, is traditionally characteristic of Negroid. But these are really just kind of guides and cannot be definitively said about an individual based on just their hair. So looking at animal versus human hair is actually surprisingly more common than you might think in a investigation, because that's the first test, is am I looking at a victim or a perpetrator's hair here, or an animal's? And sometimes in really interesting cases, pets can actually play a part in this. So a perpetrator might be linked to a crime based on the pet hair, through Locard's principle of exchange, having gotten transferred onto the victim or the scene from that person. So the pigmentation of an animal hair is denser toward the medulla. In fact, the medulla is much thicker in animals in general than humans. And so as you see here, the human hair with the medulla pretty narrow in the middle, and then ranging from all of these different kinds of shapes and patterns of different mammals even. This is a great image to show something in terms of the medulla index. So we said that animals have a much thicker medulla than humans, and here you see the cattle hair. Look how thick that medulla is. Specifically, the index is a ratio of the width of the medulla in reference to the width of the entire hair shaft. So if the medullary index is 0.5 or more, meaning that the medulla makes up half or more of the overall width of the hair shaft, then that is characteristic of an animal. And human hair is generally 0.33 medullary index or less. Other differences in the animal and human hair can be found in the cuticle. So humans tend to have the imbricate cuticle pattern, where you have this flattened and narrow, look kind of like irregular roof shingles, whereas animals tend to have either the spinous or the coronal cuticle patterns. So in using hair in investigation, obviously macroscopic investigations, just preliminarily, you can evaluate the length, the color, and the curliness of the hair. But different techniques in microscopy have been used, like phase contrast microscopy, and this is something that allows for optical microscopy to use phase shifts in the light passing through the specimen, and this increases the brightness and the visibility of the hair. Also, electron microscopes, such as this scanning electron microscope image, show really great detail. By the way, this is an image of a split end. So if you take a look at these samples here, it can reveal a few things. First, this is the comparison technique where we can actually use perhaps a comparison microscope to look at a known sample hair and a questioned hair from a crime scene to try to determine if that is in fact the same identity. And we could look at color, medullary index, we could look at the medulla pattern being continuous, and the cortex, if there's any pigmentation, the coloration in that, and so forth. Here is a image that we could actually evaluate the cuticle and the pigment granules in the cortex. And then as you see here, this is an image from the FBI hair analyst website, and you can see the absence of the medulla in this section here. This would generally be from Caucasoid hair. And as it alternates, you can see some other characteristics that might be evaluated as well. So chemical tests can actually tell a lot about a person from their hair. Not only can we try to determine identity based on those characteristics of hair that we've discussed, but also chemical tests can tell a lot in the form of toxicology with drugs that may have been ingested by the person. So I've got a list here of different drugs that can be used to analyze or can be analyzed through hair. By the way, urine tests generally tell about a person's drug activity for the past 3 days. Before the urine test. Hair, by contrast, can actually go up to 90 days before the test in terms of drug activity. And here are the things that it can test for: cocaine, heroin, benzodiazepines, which are sedatives or hypnotics, which include Valium and Xanax, amphetamines, which stimulate the central nervous system, including Adderall, Ritalin, Speed, also marijuana, opiates, such as codeine and morphine, and PCP. So a lot can be told from the hair that goes back a lot further than urine analysis. Neutron activation analysis is also a way to evaluate elements in a sample, whether it's hair or something else. And this is something that involves basically bombarding a sample with neutrons, and the elements that you're evaluating form radioactive isotopes. Since those radioactive emissions are predictable for each element, we can determine the concentration of the elements in that sample based on the radioactive decay and signature that it gives. The good thing is it doesn't destroy the sample, so this could also be used not only for hair but for art or historical artifacts. The downside is that it does irradiate the thing that you've studied, and it will stay radioactive for even a couple years after this. All right, microscopic assessment we've talked about can be done. Currently, blood tests can also determine blood type, but DNA analysis is really nice if it can be done, and it can only be done with hair if you have a portion of the follicle here. Like you see that active cells and skin that are present, which would have the nucleus with the DNA. So only if you have part of the skin tag on there, or the follicle, can you get DNA analysis. This is really common if the hair has been ripped out. If the hair naturally falls out, like you saw in the life cycle of the hair as it reaches the telogen stage, it may or may not have that follicle. In analyzing a slide of hair, it's pretty simple. You can use an adhesive like tape or nail polish or glue to adhere the hair to the slide, and you can look with your compound light microscope. And so thanks for joining us. We'll take a look at the summary here, and I hope you learned a lot about hair.